Hello. Another day, another challenge. So our current block spawning works like this. When the player approaches the edge, like let's say this black box is already calculated nodes. It knows what mining blocks to spawn. When the player destroys a block pretty close to the edge, then it's gonna spawn the adjacent box like that. And that happens all in one frame, and it's going to lead to some lag. So what we want to do instead is when the player enters block, we're gonna start spawning actually not only one but all the surrounding blocks. If we did that all in one frame, it could either crash or take very long. So make sure it doesn't crash or take very long. We're gonna have to spawn all the blocks little by little. It could be a good idea to always spawn the block straight down of the player, even though the player can be mining to the sides as well. It is gonna be the most common that they're gonna mine straight down. But yeah, we should probably do the straight down one, then the side, and then the top. and then each corner in the end. And these are these are in 3D space. I'm thinking if we need to spawn more layers of blocks, so because this is on a 2D space, right? So if we wanted to spawn all adjacent, we would actually have to do this 3 times. So the player crosses over from here to here. I guess optimally we would do this one first in that case, because the player is very close to this one. But at the same time, this one should already exist because the player, when he entered number 4, these should spawn already. This one should already exist. Which means what we have to consider when he enters this one is if we're gonna spawn this or this first. And then it makes more sense to spawn this one first. And as we can see, if he enters from here, 7, 4, 8, 3, player enter and 2, these 6 exist already because those are spawned from 4. And then if you look at the remaining ones, 1, 5, 6, we could have done a consideration that the player was on the right side and spawned 6 before 5. But I don't think we're gonna go that deep. I think it's gonna be fine without. But this is Y. This is X. I guess we can do Z as well. And we should, I guess, but then how should we do the set? Should we do the set layer the player is on and then -1 then +1, I guess? That means we're gonna iterate across Welcome. I was just putting on some toast bread. We are planning to make the spawn happen more like I'm thinking of spawning in total 27 blocks around the player, and when I say blocks I mean like chunks of blocks. So I don't know if that's gonna make the game more or less optimized, but we're gonna try that. Of course we will have to, like, spawning a single one of these chunks is a lag spike of maybe half a second. So we are going to have to spread it out over X amount of time. And when I say it's half a second of lag, that is only to calculate what kind of blocks exist here. Actually spawning in all the blocks in a chunk is probably... I don't know how much more work it is, or if it is more work, but yeah. I'm gonna start by rereading a little bit what we are currently doing before I make a new function. Just gonna go get my bread first. Yo. So how are you doing this morning, Kurt? Where are you using the music? Is it in the game or on the stream or what? I guess that's the safest if you're gonna make it commercial. if it's like one or two specific songs that you like really wanna have, then you always contact the artist or something, people that made it. That's what I did for my cat model in my first game. Yeah, sure. You want me to listen to it or what? Free sound. Copyright music and sound for creature and leisure. Leisure. You are free to use the song. Attribution not required. I suppose all you have to figure out is if this Freesound Inc. channel is trustworthy when it comes to posting songs that is actually not copyrighted. And if it is, then you're free to use it, right? Brian Eo made the music. Nice game music. Having some trouble loading. I wonder if my stream is still up. Doesn't look good. I don't think there's anything that should be using my bandwidth at the moment. Guess the internet is just being stupid. Is the stream dead? Question mark. Ah, you're still here. Okay. I was wondering if the stream was alive because I'm having some trouble with my internet. But it seems fine then. Let me know if this microphone has less trouble. If that's the case, then I'll just use this one. But it might be the internet though. So when a block is broken, we spawn nearby blocks. That's what we typically do. Okay. The download and upload is like 500 megabits, so that's not the problem. But it's probably like the Either it's like package problems or it's the fact that I have to be on Wi-Fi for a portion of the internet here. Let me know if it gets too bad and I will restart the router. The rain is something I added, by the way. That's not like the internet. So air recursion depth plus equals 1. This seems to happen. Yeah, it's nice. Trying to figure out this air recursion, it kind of seems I'm not spawning in air at the moment, I guess. No, I'm not spawning in air. Welcome back. Alright, mate. It's fine. Hope you have a good lunch. Thank you.
It seems like if I were to use air, it wouldn't work because I used the same function here without actually declaring if the extra spawning is happening because I spawned in air. The thing is, right, like since I spawned the walls in the mine dynamically, if I spawned in air, I would have to spawn in the blocks around the air block as well, so it wouldn't be a hole in the mine out into space. But this logic doesn't make sense because I added air recursion depth even when I spawn in normal blocks. So I would see very, very little air then, I think, in my mind doing this. I would have to add here when it's not part of the route. Then it would be because of air, and then I would have to do something like is air trigger or whatever, like some kind of bool that says here, like, okay, we're gonna add to air recursion. Yeah, I don't know what I was thinking here. So here we're spawning in blocks in the radius. For sure, we can do something very similar when we are adding the hey mate, someone on YouTube. Welcome. How are you doing? We could do a very similar thing to this when we are spawning in the entire cube at once. Well, thank you, Sarah. Araf. Appreciate it. Nice. First viewers from Sri Lanka, I guess. So how are you doing today? This is Godot. I just started learning Godot late last year. And it has been fun so far. So we spawn the block if needed at the position, and then we paste in a true here. Spawn block if needed. With air expansion. So here we do the check again for non-negative y values. We do it twice. Not a big deal though. It's a very cheap operation. So this generates like the chunks in the world, like the big cubes containing many blocks inside of it. Or rather, I suppose it just, this exact portion just figure out what cube we are in. And we calculate the local position inside the cube. And return those two. So all of this takes a little bit of performance, I guess, to do every time. When we are gonna spawn in the large cubes by themselves, I think we're able to skip some of this. When we mine a block, if we mine a block very close to the edge of the cube we are in, we spawn the nearby cube. If it hasn't been spawned yet. I wonder if it would be like wonder if it would actually be cheaper to use colliders or something. Let's say that you have a collider towards the edge of the cube, and then the first time the player enters it, then you just spawn the nearby cube. If it's not already spawned, and then you remove the collider. Nice. Sounds like a good lunch. Lederhosen. Thought that. Not sure what it actually is, but I thought it was some pants. Yeah, it's those things. So do you have beer for lunch in Belgium? No, in Germany, I mean. Or is that frowned upon in the workplace? Like Belgium and Germany, they're pretty big on beer. You only drank it when you were 3 and not since? You got a bad hangover at 3 and then you decided it wasn't for you? I'm actually considering adding a collider to the cubes and then just saying when the player enters the collider, you remove the collider and you spawn all the nearby cubes. Like that's gotta be cheaper than always checking the coordinates of the player or the cubes the player destroy, right? Like if I could spawn the cubes efficiently enough, that the player could never like traverse an entire I see. Happens. So my wife is from Belgium, and she told me they had some kind of beer for children. I don't know if it had like 0.1% alcohol or nothing, but apparently they had something like that. Probably nothing. Let's say the player enters this cube and it's gonna have to spawn all these cubes around. What I'm thinking, like this and this will already exist probably from entering this one earlier. So the question is, are we gonna be able to always spawn this cube at the bottom before the player reaches it? I guess one block layer like this will have to spawn as fast as the player is able to break one block. Otherwise it might not be able to keep up. Which can honestly be a little tough, because one of these layers is like 400 blocks, 20 by 20. Might be very tough. But if I start with these three layers, the layer of cube 1, 5, and 6 on top here, as the first thing I spawn, when the player enters this cube 1, I could check if cube 1 is done spawning and fall back to something similar to what I do right now if it's not done spawning yet, with dynamic spawning around the player when he mines. I'm also curious how multi-mesh instances work. I haven't looked at them, but I think I was reading a bit about that it was maybe used in Minecraft-like games. When I was looking at it yesterday. Yeah, Saraf, you're the only one watching on YouTube. There's also one watching on Twitch. Two viewers in total. That's maybe why it seems like I'm talking to myself about Lederhosen and German lunch. It's because the other guy's writing about it. Confusing multi-chat. Unfortunately, I'm not allowed to show the chat from both streams on the stream. Yeah, here it makes sense that I increase the air batch air count. And here it makes sense. Uh, I'm just trying to figure out how I'm gonna spawn in blocks efficiently in my game. That's all. Object pool. I do have I am using a object pool to instantiate the blocks, even though it's a bit of a silly object pool right now though, but the object pool was a bit weird in multiplayer. I think I can show you a little bit if I don't have any errors right now. No. Okay, so the game is a little bit about going down and mine, and then you find some find some resources down there that you bring up here and melt them. Then you buy your upgrades with the resources for the jetpack, carry weight, mining explosive, all of these things for mining and bringing stuff back up. And then you buy your weapon upgrades and you fight off waves of enemies that come every 6 minutes or so. And that's the game loop. So you basically just have to get money and get stronger faster than the enemies get strong. But I haven't made many enemies yet, like 2 of them or something. I'm still building up the core of the game. I guess you could say so. There will be a lot of mining at least. Trying to figure out what I'm doing here, like batch max recursion depth is equal to air recursion depth. What is the point of this? I started full-time in January. It's gonna be my full-time job for 1 year, and then if I don't earn money, I will have to go back to a normal job. I did it as a hobby for almost 2 years. Okay. So here we replace air with stone if we reach the maximum of recursive air spawning. So how bad is it gonna lag if we do it like that? Okay, so here we spawn some air. Didn't really feel any lag from it. I guess it's fine. Yeah, when I'm testing, I upgrade the pickaxe to one-shotting the blocks. Not gonna go through the upgrade loop every time. Let's see how it looks if I spawn in a lot of air, basically. So now there's a lot of air down here. Now it's lagging a little bit. That's great. Yeah, so with enough air expansion it does lag though. Good to know. Doesn't seem fine. I think what I'm gonna do is I'm gonna keep functionality as we have it as a backup, and then I'm gonna make a new functionality to spawn in a lot of stuff at once. Only thing. Only thing I need to be really efficient is for this this backup. When a block is broken, the check if it needs to spawn nearby blocks should be super fast. That's what I'm considering. So what I think I could do is when a cube is completely spawned, it's done spawning, I could update a variable for the cube to say like it is done spawning. And when I mine any block, I could check if the cube it's a part of is done spawning, and if that's the case, then I don't worry about spawning anything nearby. Maybe something like that. Just thinking about the edge case where you mine a block close to the edge of a cube, then it would be good to check if the cube next to it is spawned, right? wonder if I should add like cube node. So it could have depth level to decide what kind of blocks it's going to spawn, as well as the depth toughness the blocks are gonna get. Like the blocks are getting tougher when you go deeper. Could have some sort of collider. Notified when player enters the cube for the first time. I could also have the colliders be a little bigger than the cube. So let's say the collider is like this big for the middle cube here. So when a player enters the collider for the first time, that could be the signal to spawn the middle cube. The benefit of doing this is that you would spawn the cubes when you like get into range of them, basically, instead of when you enter one cube, like the middle one, you spawn every cube around, and then there's a lot of queued up spawning at once. This would be more iteratively, or whatever it's called. Yes, Godot is very beginner friendly. I think I'm gonna, while I'm thinking about this, I'm gonna learn a little bit about multi-mesh, because that is something that can be used as well, I know, to spawn in a lot of stuff. Unity was actually my first engine, and I like that one as well, yes. We need the colliders active to recognize pickaxe hits and for the explosion radius of mining bombs to find what mining blocks are in range of the explosion. So like multi-mesh, it's mostly visual as far as I understood, which is why it might be a problem to only spawn in blocks using that. You can render the blocks with the multi-mesh. Your own voxel grid data handles which block did I hit. Oh, he's thinking a lot, ChatGPT. Could be good in some cases, but it's spending some extra time. Gemini better? We could ask the same question to Gemini, maybe see if it teaches us something new. This is kind of what we're making. We have a dictionary that looks like this. And then you build a multi-mesh for each type. So the only thing we missed to make this is actually the like allocating the transforms into the right multi-mesh. We are already doing the two first steps with our current system. Well, good luck with that. It's pretty complicated. So how would you handle a pickaxe hit then? Instead of colliding against 8,000 static bodies, do a grid ray march. I'm from Norway. Probably a bit colder than Sri Lanka at this time of year. I'm not sure exactly how this grid ray march works, but I'm guessing if I'm gonna have the physics of the block work correctly and the animations of the block work correctly, then I probably need to spawn in an actual instance. Yes, that's correct. I don't think this is enough to have all the animations and physics happen with the block. I understand I can spawn in all the meshes very efficiently. The most scalable way is to have one static body 3D per chunk, many box shapes attached to that one body. I'm from Norway. Hey, update by removing shapes when blocks break. Right? Box shape. Okay. So it's suggesting a multi-mesh for rendering plus a grid-based voxel hits / explosions. Will option. My net worth is not very much. Will option A work? If we need animation such as block wobbling when blocks are hit, mesh updates when they take damage, scripts that run when the block breaks, particle effects attached to the block, etc. You animate / render per instance, and you run gameplay logic from a manager. Oh, I'm glad you stopped by. Are you interested in game development since you stopped by this stream? Kinda get the feeling that the multi-mesh do have workarounds for most things we need. Only problem is I never tried a multi-mesh before. And it sounds very different on how you like interact with the colliders, update the collider. I can't do the promotion thing, I think. Because when I drop an explosive, for example, and I'm gonna hit 8,000 blocks, they need to exist already. Otherwise, there's no point. Like, if I'm gonna promote 8,000 blocks at once, it's gonna lag. Can't just promote everything. Bubble, damage visuals, weak logic, and particles. Implemented via per instance data and transforms for the visual. Okay. Wonder how big my pool is for the explosive. No, the mining blocks. $5,000. Distant explosion sound is triggering multiple times, right? Distant explosion sound. That one is supposed to trigger when the shockwave dissipates. I guess it runs in here, maybe? The mining explosion triggered, and then shockwave. If elapsed time is over the shockwave lifetime, disable the collider. Turn off the light. And then send the signal. Play the sound. I guess we make a shockwave finished variable. scale shockwave collider. As long as shockwave isn't finished, we run this. Now it should only play the sound once. Yeah. Let's see. The mining chunk. Block type health, max health, health state, and depth toughness. It exposes methods like apply damage, break block, and apply bomb. shader reads per instance custom data. Then you add the shader and tints cracks accordingly. I wonder if I do the first approach, if I will have like a shader limit I would have to increase. That happened once before. Promote the hit block. So you can actually apply rotation to blocks using shaders. Didn't expect that. I still need to understand how the grid raycast and voxel DDA works. I don't know how that works at all. Yeah, that's smart. Group up all the changes into one big dictionary or something that is updated. Could probably also just synchronize the dictionary with the changes, I guess. Set it to unchange. And then apply a function when the dictionary changes. Oh. Yo, Ember After Dark, welcome. Start with Conway's Game of Life. Is it YouTube video or something? I see. But I do have like the procedural generation part ish how I want it. Like I have an idea of how I want to do that. Problem is I'm trying to figure out how to spawn in tens of thousands of blocks quite fast without having any performance issues. Here. Mesh optimization. The engine combines thousands of blocks within a chunk into a single low polygon mesh, which significantly boosts rendering performance. So how does Minecraft solve it if you're gonna blow up something with TNT then? Because the blocks behind the wall also have to be calculated into the explosives, right? That doesn't have anything to do with rendering though. It's just the collider itself. Either the explosion has to either it has to connect with the collider or maybe we could just iterate through the blocks in a specific range from the multi-mesh instance. Yeah, the low polygon mesh, it will have to update every time a block breaks, right? This one? blocks are stored as 4-bit, 8-bit, or 16-bit IDs. I see. It's Godot, yeah. From what I understood, it's possible to make like a thing, like a large multi-mesh here as well with the one static body, and you update it by using like a lot of block shapes. So even if we change a block, we don't have to rebuild the entire thing. You update only one instance transform for wobble. Swap the instance you want to remove with the last instance. Silent Godot the voxel. Okay. So what are voxels exactly? Are those the colliders? Volumetric pixel is voxel. Voxels are transformed into chunked meshes to be rendered. Now I know C++ can help performance for sure. But to make it more performant than what I have, I don't think I need C++. But to make it the most performant it can be, I would need C++ probably. True. I never used like remade anything in my game as far as I can remember. It will probably have a lot of features that I don't need. It will probably contain most of the stuff that I do need. And there might be some features that I would have to add, depending. The question is like, how hard is it to make myself when I don't know anything about this? It's likely then that using a pre-made one and editing it will be less work than making one from scratch, I guess. So swapping out meshes with a multi-mesh is expensive. But if I can use a shader to apply the damage to the block, then multi-mesh is cheap. I'm not sure how my blocks will break in my game yet. A safe fallback will always be Minecraft and Hytale and just make cracks. That is very simple, I guess. That can probably be done with shaders. I'm guessing the first... Oh, you can do the... You can remove chunks of the block as well with shaders, okay. That's interesting. You create a noise texture, 3D noise, plus the damage amount, and then you... discard pixels. You can also do stuff like fading edges, add glowing edges, or dust. I'm not gonna start trying to understand how to make the shaders now, but it's important for me to know that shaders that show damage on a block is doable, so that I know what options I have for a multi-mesh. I don't think I'm going to need holes in the block though. Real geometry chunks missing. Most correct, most work. Ah. I see. And if most are built on C++, the AI is probably gonna understand how to build it in C++ a lot better as well, since there's more examples to learn from. Performance, effects, mining, mining block shaders upgraded. Have damage state visualized via shaders. This is more performant than changing the mesh, especially if we are using multi-mesh. You think any decent sized voxel in GDScript would lead to hitching, so like lagging then? Because creating a voxel world creates a bunch of trash for the garbage collector. The garbage collector will get overwhelmed and cause stuttering. To make the multi-mesh version of spawning chunks. Okay. Raycast into the grid to pick blocks. I think I can have like when it comes to the toughness of the block, like the toughness increases the deeper you dig, but when it comes to the toughness of the block, I think I can easily just say that each entire chunk uses the same toughness. I think that's fine. It actually fits pretty well that every 20 blocks or so upgrades the toughness anyways. Why I'm saying this is because it really reduces the possible number of different meshes we're gonna need. So if we only need block type, and then like one mesh for each block type, and then we make a shader that applies I guess the shader can also apply the depth toughness actually, but shader applies the depth toughness, the amount of damage to the block. I guess textures are also possible to put in shaders, right? I do have textures in one of my shaders already. Where did I use that one? Well, I guess I can check the shader here. Here's an example of the shader. This is a shader material. It has an albedo texture in it. And a toughness tint. I would still need to apply the correct textures though, of course, but my point is that I don't need to necessarily have a different material for each block. I just have to update the texture to the correct one. But maybe that's more work than actually just having a pre-made material with the correct texture and everything, and getting and using that. Oh well. I want to learn about multi-mesh and voxel. First step. First question. When one block is destroyed from a multi-mesh, we need to update the collider. Is the collider one big voxel? What is a voxel? Is it used for the collider? Question 2. When one block is destroyed, we need to update the collider. A grid raycast. How does a grid raycast work compared to a normal raycast? Let's start with this and see if we can understand something. A voxel is a 3D pixel, a cell in a 3D grid. It stores values. Voxel is a data, not a physics process, not a physics object. In a voxel style system, you typically do not have one collider per voxel. Instead, you use the voxel data to answer gameplay queries. Okay, so the hits are okay. Then how does the player collide then? How does a player collision work versus voxel data? Normal raycast, you shoot it into the physics world and test for colliders, and you get the collider that is hit. With a grid raycast, you shoot the ray into a 3D grid, your voxel chunk data. Instead of testing triangle shapes, it steps through grid cells in the order the ray passes through them. The first non-empty cell is your hit block. Physics raycast cost depends on the colliders in the world, and the DDA cost depends on how many grid cells the raycast crosses. Okay, I think I understand that part. So the DDA raycast, whatever, grid raycast, doesn't actually collide with anything. It just every time it enters like a new part, a new block in the 3D grid, it checks if that block is empty or not, and if it's not empty, then it's a hit block. Doesn't use colliders. Imagine the ray moving through cubes. DDA is the math that figures out which cube boundaries you cross. Cross next. Okay, so what about players walking into blocks? So either we can use voxel collision checks. When moving, you test the player's capsule AABB against solid voxels near them. It works well, but it's bit of work to implement. Then we have chunk level collision, mesh shape for player only. You generate update collision for the terrain in bigger pieces. And this part is heavier when the blocks change a lot. And since we are changing the blocks a lot, we probably want to use the voxel collision checks then. Since you need a multi-mesh for visuals, you can also keep a collider that represents the chunk. So you keep one static body 3D with many box shapes. So when you remove a block, you only remove the shape that corresponds to the block. But this is still heavy. This is also costly. We can make some notes of what the most efficient system could look like, and then see if it's something that we might be able to create or not. Creating an effective spawn mining block spawn system. Multi-mesh. A multi-mesh per block type is the most efficient way of spawning many blocks. Voxel-based collision with the player or the mining and mining raycast, grid raycast. Is most performant. Collisions. Player. Mining. Explosions. So the bomb itself should also have like a voxel-based collision, and then the explosions should just iterate through grid pieces in its range and not use any sort of collision. My chat recommends C++ for any voxel generation system. I am only used to Godot GD script. What do you recommend I do? So even if I don't know C++, it's not that hard to make a small piece of the game use C++. It's only a bit more work whenever I'm gonna change anything there, since I have to like spend extra time to understand what's going on and what kind of syntax could be wrong and things like that. But C++ is also something that AIs are a lot more confident with, so they might be able to help out a bit more if I get stuck on something. Store block data in arrays or dictionary maybe. One multi-mesh per block type and implement the generation chunk from noise. VD array hit. Okay, so this part I think I can reuse what I got, and then I would just have to, as I create the chunk, I guess I would update the multi-mesh during generation. So for example, I put all the stones together in the same multi-mesh. I don't remember how long I spent to make the current generation system. Like, the question is, should I just do it from scratch or not? Or should I reuse a lot of what I got? It's been so long as well that maybe I'm able to make it a little better. So if it's fast, I should. If I spent a lot of time on it, maybe I shouldn't remake it. There's a lot of lines of code at least, but a lot of these are most of it is generation though. So, to-do list. Create dictionary. Should I have a dictionary on top of the multi-meshes though? Create dictionary with key vector 3 I XYZ value block type and then for the multi-mesh store store block in multi-mesh of block type. Something like this then. I guess we could just like start at step 1, like we know we're gonna need a chunk dictionary and the multi, and we know we're gonna need a multi-mesh for each block type. So we can just generate those first, and then we can learn about how the DDA array hit works, and then how the collision with the player and the bomb works. Step by step. A multi-mesh with positions not adjacent, such as x equals 3 and x equals 7 is no problem. It will be able to show meshes in both locations, like that. Okay. Just checking in case. Is this fine for a first step? And should I keep dictionary or not? I imagine dictionary is an easy way to iterate blocks during explosions. But is an extra list that we might not really need, since explosion could iterate through positions from the multi-mesh lists, maybe? You tell me. Use a 1D array for the chunk, not the dictionary. A dictionary with vector 3i keys is convenient, but it's more memory slower than array indexing. And more GC. What is that? Global computing or something? I don't know. GC. Hashing overhead, especially with bombs. For a fixed size chunk, a packed int 32 array or array of int is ideal. Gonna take 5 minutes before I try to understand the 1D array. Be right back. Oops, my microphone were muted. Hello. Like, I've realized that the task that we've taken on right now, it's basically rebuilding the block spawner, changing how the meshes are chosen. We need some better shaders to apply the wobble and stuff, and the damage of the blocks. There's new logic when it comes to stuff like blocks taking damage, when it's like blocks breaking, how the particle effects spawn. Like, there's a lot of stuff that changes now. The good things are that we did already make a noise map and a spawn system before, so it's gonna be okay to remake that. For the particle effects and things like this, they exist. The scripts for the blocks to take damage exists, like these things. So even though we're gonna have to tweak a bit when the logic happens, a lot of the logic stays the same. You know? Sample noise, decide block type, store it in block type index, add its transform to the correct multi-mesh list. So we're actually... I see. So we have a 1D array for every variable, and the index is the location. So we will have 8,000 indexes. 8,000 indexes for each place. Guess we drop max health, we only use health. Health state. That might be good to have. Not sure. Maybe. The thing is, when the health crosses a threshold, it's calculated, right? The health state. Let's say we have the mining block, the health state. So when we deal damage, we actually check here how much percentage health is left, and then we reduce the health state based on that. So instead of reducing the health state here, we could change the shader, right? Shader material. Size vector 3i. How the XY set position the indexes. Can you tell me a little about how multi-mesh works? Do I set one mesh to the multi-mesh, and then that one mesh will spawn at specific locations? Spawn at a list of locations given to the multi-mesh? One mesh, one material, many transforms. So multi-mesh mesh is cube mesh, multi-mesh instance count 2. We have to set how many we're gonna spawn, and then transform number 0 and number 1 to this location and this location. Okay. That one mesh. One material. Many transforms. Instances. Okay. My phone doesn't charge anymore, unlucky. Have to get a new one. Already repaired it once. It's like 8 years old or something. Alright, so I'm gonna eat, then I'm gonna go run some errands, shopping, maybe get a new phone. I'll see. And I'll be back and continue struggling. We don't make a dictionary, create a 1D array or block type index. where index is set as this array is able to track x positions x, y, z, and is cheaper than a dictionary to use. Consider what other arrays we are going to use. Previously we had max health, current health, health state, and depth toughness. We might get away with what is the least we can do? Skipping health state and depth toughness. Depth toughness can be same for all blocks in same cube. Instead of updating health state, we can update the mesh immediately when a new health state would have been reached. The thing with current health and max health is that we use that to calculate the health state. If we only track the health, let's say we have 100 health on a block and it has taken 50 damage, it's now at 50 health. If we don't have max health, then how are we going to know if we don't have max health, then how are we going to know how many % of the health is gone? Maybe we could do like each block type has a multiplier to max health, right? For example, a normal stone block has 3 health per depth toughness. While, for example, iron has 6 max health per depth toughness. So we could maybe use depth toughness as the only variable for health. And we will use it in combination with the block type. So we could do something like skip all health variables and instead calculate health based on depth toughness. Well, that would calculate max health. Max health based on depth toughness and block type. When checking if we reached a new health state. Threshold, which we now only change the mesh. When we now only update the mesh. Current health we're going to need though, right? So we're gonna end up with needing the index arrays we're gonna need are going to be we do all this final arrays we need to keep track of for each index is going to be block type and current health. Those two. If we reduce the number of arrays we use by doing this, is that worth it? This would mean we calculate max health each time we look at percentage of damage done if the block is not one shot. And it would be calculated as depth threshold, which is the same for all blocks in chunk and on block type. So it's like reducing the number of arrays needed versus a bit more computation each time a block takes damage, which doesn't one-shot it. What do you think is best? Can't keep everyone waiting for me at the dinner table. I'm gonna go. Thank you for watching, and